February, March 2018, paper 3, variant 2. Question 1. We have a pile of paper. Okay. Pile contains 500 sheets of paper. Calculate the average thickness of one sheet of paper. How can I find the average thickness of one sheet of paper? I have 500 sheets of paper. How can I find the average thickness? Can someone tell me? Any ideas? Yes. Well, hmm. Hmm.
الهايت ديفايدد اللي هو قصدي ال 500 ديفايدد الهايت اللي هو 5 سنتيمتر.
500 divide 5?
5 divided 500,
Well,
0.01.
5 divided by 500. Now, in this case, we need to divide the thickness by the number of sheets. 5 divided by 500, which would be 0.01, which is يعني a realistic thickness for a sheet of paper. 0.01 centimeters, 0.1 millimeters. That is very thin. Okay. Show that the pile of paper has a volume of 3,000 centimeters cubed. How can I find the volume? It's quite easy.
Uh,
Volume equals um yes, قولي لي.
هنعمل area of base times height.
Okay. Volume equals area of base times height, which is, what is the area?
30 times 5.
30 times, okay, 5 times length times width times height, which is 30 times 20 times 5. 30 times 20 times 5, which is definitely 3,000 centimeters cubed. Correct. Okay. Student measures the total mass. What's the device we use to measure the mass? Yeah. What is the device? Anyone?
Balance.
Balance. Correct. Okay. It is the balance. The mass, calculate the density. Density equals
mass over volume.
density equals mass over volume. The mass is 2,400 grams, and the volume, we just found the volume, which was 3,000. Okay, 2,400 over 3,000 is 0.8. Okay, quite easy. Okay, yeah. Next question. Some cyclists are racing around the track. Now we have a speed time graph. Speed time graph. What is the okay? Tick the box that represents the cyclist traveling at a constant speed. Definitely. Where is the constant speed? Where's the
B.
constant speed? B.
B.
Correct. Okay. Calculate the distance traveled in the first 5 seconds. Distance traveled first 5 seconds. Speed time graph. What should I do?
area under the graph.
Area under the graph. In the first 5 seconds, this is an area of area under the graph. In the first 5 seconds, this is an area of what? This is an area of
Triangle.
triangle. Half times base times height. This is 5 seconds. The base is 5 and the height is 20. So, يلا. Half times base times height. So half times 5 times 20. Total 50 meters. Okay. Easy. The length of the track is 250 meters. Another cyclist goes around the track 4 times, 4 laps. It takes 80 seconds. Calculate the average speed. How can I find the average speed? يلا. قولي لي كده.
هنعمل 250 times 4.
Okay, so total distance is 250 times 4. Total distance is 250 times 4, which is 1,000 meters. Okay.
وبعدين هنعمل distance over time فهتبقى 1000 over 80.
Okay, speed equals distance over time, which is 1,000 over 80. 12.5 meters per second. Okay. You have a question? Okay. Calculate the time taken for the cyclist to go around the track during the second lap.
هنعمل 43 minus 43.88 minus 20.16.
Okay, so this is the time. On figure 2.2 shows the reading stopwatch that has gone around the track once. 2.3 shows the reading twice. Calculate the time for him going during the second lap. Okay, the second lap would definitely be 43.88 minus 20.16. This would give a time of 23.72 seconds. Okay, good. ماشي. Determine the extension of spring A for a load of 10 newtons. Spring A. How can I find the extension for spring A for a load of 10 newtons? What should I do? يلا. Zoom in.
نرسم لاين فيرتيكال ويروح هوريزونتال لما نلمس ايه.
يعني we should start from 10 and move on vertical? Are you sure about that? ها.
لا بالعكس.
آه.
10 النيوتن.
10 newtons صح. He said 10 newtons. What should I do? I'll draw a horizontal line until I reach spring A, and then I will draw a vertical line from spring A until it reaches the x-axis. Okay? This would give a reading of 12.5. This is in the center of the square. 12.5 centimeters. Millimeters. Sorry. Okay. State which spring is easier to stretch and give a reason for your answer. Which of these springs is easier to stretch?
spring A.
بي يا مستر.
B ولا A? You said A, you said B.
بي عشان لما اللود بيكون أقل
D.
الإكستنشن بيكون أكتر.
Okay. B, it is correct. Why is it B? Okay. Why is it B? Using the same force, let's say 10. Spring A was extended 12.5 millimeters, but spring B was extended 17 millimeters. Using the same, using what? Using the same force. I extended A only 12.5 centimeters, but I extend B 17 centimeters, so B is much easier. B is definitely much easier. Yes, spring B. Why? Because it's much easier. Using the same force, B extended more. Okay. Okay. Hello. With no load, okay, with no load on the spring, the pin points to 19.7 centimeters on the meter ruler. When a load of 6 newtons is attached, the spring, okay, to the spring, the pin points to 43.9 centimeters. Calculate the extension. How can I find the extension?
هنعمل subtract.
Subtract. 43.9 minus 19.7. That's it. 43.9 minus 19.7. This would give a reading of 24.2 centimeters. Describe how a student could use the equipment to obtain an accurate reading. How can he use this equipment?
مستر حضرتك يا مستر بعت 2019.
لا, I sent both. Okay. How can I find the reading now? How can I find an accurate reading? Describe how the student can use the equipment. Take the reading perpendicularly. Okay, could be one of the answers. What should he do? He should use the ruler to take the initial reading as he did. And then he needs to measure the reading for more than one load. I cannot use only one load. You can never use only one load. You have to use more than one load. Okay? That's the whole point of any experiment. You cannot do it only once. You have to repeat it more than once. Okay? So use or measure the extension for more than one load. Okay, that's one of the uh measure the extension for more than one load, more than one force. Okay, what should I do then? What should I do again? Once you measure, sorry, once you measure the extension for more than one load, what should you do? You should repeat and take average. Okay, you have to repeat and take average, and then take the reading. You can say also take the reading perpendicular. Repeat and take average. Yeah. You can also take the reading perpendicularly. Okay. Okay. Next question. Describe how the power station uses uses the water in the reservoir to generate electrical energy. How can I use the water to generate electrical energy? Any ideas? I have some water in this reservoir and I need to generate some electrical energy. Okay.
الووتر بتموف ترباين والترباين بيموف جنريتور فبيجنريت electricity.
Okay. 2 out of 3. Okay. You take 2 out of 3 marks.
هو
سؤال.
الوتر ويفز وهي بتتحرك بتعمل اير موفمنت، فالاير هي اللي
لا
بتلف
لا لا لا. This is
الترباين
not.
بتعمل
This is
بروديوس الكتريسيتي.
no. This is not. I'm not producing electricity due to waves. No, I'm not producing electricity due to waves. No, it's due to.
البريشر.
The reservoir push the water on the اسمه ده on the turbine, then the turbine it will turn the generator.
Okay, again,
بس
the
في
2 out
الآخر
of
will turn
3. I need to find the initial. شباب, I need to find the initial
Later, is it gravitational potential as it goes
gravitational
down?
potential energy. Yes, you have to say that initially the water had gravitational potential energy. Yes, it had gravitational potential energy. And as it moves down, this gravitational potential energy starts to convert to kinetic energy. Okay, so gravitational potential energy in the water changes or transfers to kinetic energy as it moves in the pipe. This kinetic energy, this motion, this movement of the water, what does it do? This rotates the turbine, which rotates a generator. We have a turbine, we have a generator. Turbine is always attached to a generator. Okay, this turbine rotates another generator, and then what does it do? Which produces electrical energy. Okay. 3 advantages. We need 3 advantages of generating electrical energy using hydroelectric system compared with using a coal fired power station.
Not air polluting.
Not air polluting. Okay.
renewable reliable.
Reliable لسه هقول.
Renewable. Both of them are reliable. You cannot say reliable. No carbon dioxide pollution. You cannot say that it is reliable compared with the coal. Actually, the coal is more reliable than the hydroelectric power station.
بس أنا عندي سؤال.
Hmm.
وأنا ممكن أقولها إن هو مش محتاجة هيومنز وكده عشان الهيدرو إلكتريك سيستم.
لا, it does need humans. شباب, you can say two types of pollutions. That's the whole point of saying, that's the whole point of not just saying it doesn't pollute. Okay. No pollution. No, you can't say no pollution. No pollution is wrong. You have to say what type of pollution. That's why I wrote down no carbon dioxide pollution. Okay. You can also say no greenhouse effects. That's another advantage. You have two advantages. You can say no acid rain. Okay. Yeah, it doesn't use up fossil fuels. That's another advantage. You have many advantages. Okay. Doesn't use up fossil fuels. Okay. Okay. Hmm. Have an electric drill. This usefully transforms electric energy into what type of energy?
Kinetic energy.
Into
kinetic.
kinetic energy. صح.
kinetic.
A second drill transforms the same amount of electric energy per second as the first one. It wastes more of this energy, so it's less
Efficient.
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 Okay. I have a glass bottle. State what happens to the pressure when it becomes warmer, when the air becomes warmer.
Increases.
Increases.
Pressure increases, correct? Increases. Okay. Why does the pressure increase in terms of molecules?
عشان the molecules will gain kinetic energies and they will start colliding more and they will form more pressure on the bottle.
Okay. As the pressure increases, as the temperature increases, kinetic energy increases. Molecules move faster. Molecules move faster and they collide. I cannot say collide. I cannot just say collide. You have to state that they collide with the walls. You have to say that they're hitting the walls. Okay, you can never say they collide, for example, with each other, or that they just collide. You have to say they collide with the walls. With the walls faster and harder. Okay, faster and harder. And sometimes you can say and more frequently. And more frequently. When they collide faster and harder more frequently, they increase the force and they increase the pressure. Increasing the force and pressure. Okay. Yeah. The bottle has a weight of 5.4, an area of 9.2. Calculate the pressure and give the unit. One of the easiest questions. Yeah. Pressure equals
Force over area.
and force is
5.4 over 9.2.
9.2, which would give a pressure of
تمام.
0.6, I guess, or 5.9. 5.9. Newtons, don't forget the unit. Newtons per centimeter squared. Newtons per centimeter squared. Okay? Okay. I have another bottle. Figure 5.3 shows the base of the bottle. The shaded area is not, it is not in contact with the table. The base of the bottle is circular. The radius of the outer circle is 4 centimeters as shown. Calculate the area of this circle.
Pi r square.
Pi r squared. Which is pi times 4 squared, which would give a final answer of 50, maybe. 50 centimeters. The bottle shown has the same mass as the bottle shown in 5.1. Explain why the bottle in 5.2 exerts more pressure on the table. Why does it exert more pressure? يلا.
more surface area,
More surface area?
less surface area.
Less surface area. Okay. Less area, not surface area, less area in contact with the table. Okay. Okay.
ثانية بس أنا عندي سؤال.
اه
هو مش لما احنا نصغر الأوبجكت السيرفيس اريا بتزيد؟
لا. هنا he said he had the bottle. He has two bottles. One of them has a large surface area, the other one has a smaller surface area. What's the surface area of this bottle? It's only the unshaded region. Okay. This blue part. This is the area in contact with the table. Therefore, when it has the same mass, it has the same weight, it has the same force. When applied over a smaller area, therefore the pressure increases. Okay. Okay, thermometers, I know thermometers were cancelled, but state a physical property that varies with the temperature that could be used in a thermometer. You're actually required to know this part, not due to thermometers, but you need to, what is it?
thermal expansion.
Okay, thermal expansion, صح. Physical property that varies, thermal expansion, which means that the volume expands. Okay, the volume expands. You need to state that the volume expands. Yeah, you don't actually need to say thermal expansion. You actually need to say the volume expands. Okay. Okay. Moving on to the next question. Heater in the room is switched on at 6 p.m. The room has a large window. A large amount of thermal energy is transferred through the window. The windows in the room has a thick curtain. Oh, I like this question. Has thick curtains. Closing the curtains reduces the loss of thermal energy in the room. Suggest the time at which the heater is switched off. When is the heater switched off? When do you think the heater was switched off? I have a heater, and the temperature in the room kept on increasing. When do you think we switched off this heater?
8:30 p.m.
8.5.
8:30. Yes, 8:30. 8:30, not 9. Why is it not 9? It is 8:30. What? Because initially when I switch off the heater, this temperature will start to drop. At 9 it was dropping as well, but initially it started to drop when at 8:30. Suggest the time at which the curtains were closed and explain your answer. When did I close the curtains?
9 p.m.
9 p.m. Why was it 9 p.m. بقى؟
كان الهيت لوس قل أو التمبريتشر بدأت تقل بس بريت أقل.
الهيت loss, our rate of losing heat started to decrease. Close. Okay. The slope decreased. The rate of heat loss decreased. Okay. Air is a good what? Conductor, conduction, convection, emitter, insulator, radiation, radiator,
insulator.
insulator. Definitely air is a good insulator. When air is trapped between fibers, it reduces heat loss by
conduction
وconvection.
conduction يلا
convection.
and convection.
وconvection.
correct. ماشي. Which angle is the angle of refraction? Quite easy.
Z.
Z.
Yes. State another example of a transverse wave. Light is transverse. What is one other example of a transverse wave?
Radio waves.
Okay, radio. Sound is wrong. Sound is not a transverse wave. Radio waves, microwaves, whatever electromagnetic waves, they are transverse waves. If you say, for example, water waves, they are transverse waves. Okay. Now I have some wavefronts going through a narrow gap. What should I do?
يا مستر بالكومبس صح؟
Using the compass, because this is a narrow gap. Whenever you have a narrow gap, what should I do? I should draw it using a compass. Okay, draw 3 wavefronts that have passed through the gap. Initially, I have the compass. I'll put the pin, okay, the pointy edge in the center of the gap. Should I open it to the first wavefront? No, that would be quite hard in this question. Don't open your compass to the first wave front. Open it to the second one, which would be much, much easier in this question. I'll open my compass to the second wave front. And then on the other side, what will I do? I'll draw a semicircle. And then I'll open the compass onto the third wave front. And then on the opposite side, I'll draw a semicircle. Okay. All of this while the pointy edge is in the center of the barrier. Do not remove the compass from the center of the barrier. It has to remain in the center of the barrier. Okay? And then drawing the third wavefront, I'll open it to the fourth one here. And then draw a third semicircle on the opposite side. One. Anyway. State the name of the effect. What is this effect? يلا قولي لي.
Diffraction.
Diffraction.
Diffraction. صح. Diffraction. Sun sets up an electrical circuit. She draws part of the circuit. On figure 8.1, draw some symbols. I need something to measure the total current. I need something to vary the current in lamp B only, and I need something to measure the potential
Ammeter?
difference. First one, to measure the total current, is the ammeter. Where should I draw the ammeter?
يمين اللي هي جنب ايه؟
انتري.
On the right.
Inseries جنب
الفاضية
السل.
Okay. To vary the current in lamp B only, what should I
variable
use?
resistor هنا
vary
الحتة الفاضية دي.
resistor جنب
Variable
اللامب
resistor
B.
next to lamp B. And then to measure the potential difference, I need to draw a
voltage
voltmeter in
voltmeter in
parallel.
parallel.
okay, voltmeter in parallel above or below lamp B. Student differ. Okay, above or below lamp B. Okay, good. The lamp in A is 0.2 ammeters. The current in the lamp is 0.2 ammeters. The potential difference is 6. Calculate the resistance. Resistance is what's the
0.2
resistance?
over 6.
V over I.
Okay, R equals V over I, 6 over 0.2, which would give a total resistance of 30 ohms. Okay, quite easy. ماشي. Figure 9.1, one region is not named. What is this region?
X-rays.
State which region has the longest wavelength.
راديو.
راديو.
Okay. Radio waves. Lowest speed in air.
ultrasound.
Ultrasound. صح. Because it's a sound wave, which has a speed of around 330 meters per second. A group of students want to determine the speed of sound in air. Describe a method they can use. State the measurements they need to make. Okay. Again, theoretical question, you need to just write. It's easy. What should they do? We have two students. We know this experiment. We know we have two students. One of them has a stopwatch and the other has a smoke gun. They have to measure a long distance. Yeah, let's write it down. Student A has a stopwatch. Student B has a smoke gun. They measure a long distance, and we will name this distance D using what? Using a tape measure or a measuring tape. Measuring tape. And then when student B fires the smoke gun, once he fires it, when he fires the smoke gun, student A starts the stopwatch, and then what should he do? When student A sees this, or when he hears the sound, he will see the smoke first. He will see the smoke first. That's why he will start the stopwatch. When student A hears the sound, okay, he stops the stopwatch. And records time t. Yeah, and records time t. And then I can calculate speed equals distance over time. That's it. You have to measure long distance. Usually this distance probably is above 300, 400 meters, maybe up to 500 meters, using a measuring tape or using whatever device, but you cannot use a meter ruler. And then when student A or when student B fires the smoke gun, student A will see the smoke at first, so he'll start the stopwatch, and then when he hears the sound, okay, he will stop the stopwatch, because there's a huge difference in the speeds between the speed of sound and the speed of light. When he stops the stopwatch, he will record the time and calculate speed equals distance over time. Okay. ماشي. Moving on. I have a spring, a magnet, voltmeter. Describe and explain. What does the teacher do? The teacher pulls the magnet until one end is inside the coil. The teacher then releases the magnet. The magnet moves up and down repeatedly, keeps on moving up and down. As it moves, one end of the magnet enters and leaves the coil. Describe and explain the readings on the voltmeter as the magnet enters and leaves the coil.
deflect. الإفكت هيرجع لما
Huh. Okay, so it deflects. Okay, it does deflect. How does it deflect?
لما يطلع فوق هيعمل ديفليكت لدايركشن معينة، ولما ينزل لتحت يعمل ديفليكت للدايركشن التانية.
Okay. Okay. حلو. So So yes, it's correct. We will say what? We will say that the voltmeter keeps on deflecting to the left and to the right. Why? Because the magnet keeps on cutting the coil. Because the magnet keeps on cutting the coil, or the magnetic field, to be more accurate. The magnetic field of the magnet keeps on cutting the coil. Okay? And it keeps on cutting it in the opposite direction, once upwards and once downwards. It's quite easy. You just need to think about the direction of the motion. Once it moves upwards, it will deflect to one direction. Once it moves downwards, it will deflect to the opposite direction. That's it. Yes. As, for example, as the magnet moves downwards, the magnetic field lines, the magnetic field lines cut the coil, and the voltmeter deflects in one direction. Okay. As the magnet moves upwards, what happens? It deflects in the other direction. It deflects in the other direction, indicating a current produced in the coil. A current, or you can say induced, which would be much better. Current induced okay. So what do I mean by cutting and what do I mean by deflecting? The magnet has a magnetic field. This is the magnetic field of the magnet. It has a magnetic field. These magnetic field lines are invisible. You don't actually see these lines, but they are there. What happens as they move upwards and downwards? What happens? They pass through the coil. They cut the coil. Do they actually cut them using scissors? No, they just pass through the coils. Passing through the coils is what we call cutting the coils. Okay, so these magnetic field lines, they cut through the coils, they pass through the coils. As they pass through the coils, a current is induced in the coil. When the current is induced in the coil, what do I mean by induced? The current is created, the current is generated in the coil. Whenever you have a current generated or produced in the coil, what happens? The voltmeter starts to deflect. Initially, the voltmeter was zero, it was reading zero. When it deflects, it could deflect to the left or to the right, indicating a current is passing through the coil. If the current is moving in one direction, for example, it will deflect to the left. If it's moving in the other direction, it will deflect to the right. That's the whole point. Okay. That's the whole point of electromagnetic induction. Induction means that I'm producing current, that I'm generating a current. That's it. Okay. That's it. Okay. Yeah. Moving on to the next question. This is an easy question. State the name of the device used in X and the device used in Y. X, I had a voltage of 22,000, and then the voltage became 132,000. Okay, and then after Y, it became 240. What's X and what is Y?
X step up or Y step down transformer.
Step up and step down transformers. Step up because the voltage increased, and step down because the voltage decreased. Step up transformer, step down transformer. Okay, quite easy. ماشي. Student rubs a polythene rod with a dry cloth. describe and explain how the rod becomes negatively charged. How does it become negatively? Quite easy.
Gains electron.
gains electrons.
Gains electrons from where?
Dry cloth.
From the dry cloth. Okay.
بيصيروا عليه 3 درجات، مش هنكتب أي حاجة تانية.
Gains electrons dry cloth. 3 marks. Okay. You can say due to friction or whatever. It doesn't matter. Describe and explain what happens when the negatively charged rods are close to each other. You have 2 negatively charged rods. What will happen?
repel.
Repulsion. Okay, to move away. Because like charges repel. Okay, quite easy. Radioactive source emits beta particles. Describe and explain how could you show that it's only emitting beta particles.
هنجيب
هنحط
aluminum
ألومنيوم
sheet
فويل.
paper.
Okay. If you put the aluminum foil initially, that would be wrong.
أول حاجة هنعمل measure للإيميشن الأول من غير أي حاجة.
Okay, so without
وبعد
any barriers, we have to
بعدين
measure.
هنحط
Huh.
paper as a barrier وبعدين
Okay,
aluminum وبعدين lead.
okay, and
والمفروض
then
بقى إنها تقف عند الألومنيوم، مش هتعدي تاني.
bas correct. Okay, so initially we need to measure the reading without any barriers. Measure the reading of the emission or of whatever, okay, without any barriers. And then put or add a sheet of paper between the source
بس أنا عندي سؤال.
and the detector. ها
احنا في سؤال زي ده المفروض نقول positive result مش صح؟
اللي ايه؟
لو الحاجة موجودة لو result positive يبقى هنكتب الريزلت مش صح؟
اه
لا.
Hmm. Okay. Add the sheet of paper between the source and the detector. The reading shouldn't change. Okay. The reading shouldn't change. And then add a thick sheet of aluminum also between the source and the detector. The reading should be, in this case, the reading should drop to 0. Okay. Why? Because beta particles are stopped by thick sheets of aluminum. Okay. That's it. Okay.